This lesson is about ozone depletion in the atmospheric layers. The important constituent of the atmosphere is ozone, that is O3. It is found mostly in the layer which is termed as stratosphere. Ozone is present in the lower region of stratosphere, that is between 25 to 30 km from the earth's surface. The presence of this layer is undoubtedly a boon to humanity. In fact, the ozone layer acts as a filter for the ultraviolet rays of the sun. In the absence of the ozone in the upper atmosphere, the much harmful ultraviolet radiation would reach the earth in large amount. Now, there is a current international concern over the growing ozone hole over the south and the thinning of the ozone layer around the globe. The environmentalists, the scientists from the various fields are involved in doing research work and keenly watching the depletion of ozone in the stratospheric layer every year. Now, let us see the discovery of ozone hole in the atmosphere. First, the ozone hole was noticed in 1979 in Antarctica, that is in South Pole. Its area is increasing every year and it has been found now to cover South Australia and New Zealand too. In 1985, using satellites, balloons and surface stations, a team of researchers had discovered a balding batch of ozone in the upper atmosphere, the size of the United States over Antarctica. Today, almost 25 years later, the reports continue of large ozone holes opening over Antarctica, allowing dangerous UV rays through to the earth's surface. Indeed, the 2005 ozone hole was one of the biggest ever, spanning nearly 24 million square kilometer in area, nearly the size of North America. The important formation of the ozone layer is O3, that is O2 equal to O plus O, then O plus O2 that equivalent to O3. Any mechanism which disrupts or interrupts the above cycle lead to ozone depletion. Since the ozone gas constitute merely 0.00006% by volume in the atmosphere, but it is the most efficient absorber of the burning ultraviolet radiation from the sun. Owing to its nature, all must know the significance of the ozone layer. Evidence exists to confirm the origin of life due to the existence of this layer. The O3 layer has reduced the effect of ultraviolet radiation, thereby making the life possible on the earth. Sun emits its energy largely in the form of electromagnetic radiation. It includes short waves, visible light and long waves. Ultraviolet rays are one among the short waves emitted by sun. The ozone present in the upper atmosphere absorbs and thereby prevents the ultraviolet radiation from reaching the earth's surface. This process protects the earth from harmful effects like skin cancer, eye problems, genetic mutations, etc. The ozone layer, which acts as a shield for us from very harmful ultraviolet rays. If we damage the ozone layer any more than we would put ourselves at an increasingly greater risk. Without the ozone layer, we would not be able to survive. Measurement of O3 concentration. Now, let us see how the ozone concentration is measured. O3 concentration is measured by Dobson spectrometer. The ozone is measured in Dobson units named after G.M.B. Dobson, who carried out pioneering studies of atmospheric zone between 1920 to 1960. The thickness of ozone 3 also varies little from day to night. The following points tell about the relationship between atmospheric ozone and ultraviolet radiation. Ultraviolet radiation is a high energy electromagnetic wave emitted from the sun. It is made up of wavelength ranging from 100 nanometer to 400 nanometer. The ultraviolet radiation includes UVA, the least dangerous form of UV radiation, with a wavelength range between 350 nanometer to 400 nanometer. The UVB, with a wavelength range between 280 nanometer to 350 nanometer, and UVC, which is the most dangerous between 100 nanometer to 280 nanometer. UVC is unable to reach the Earth's surface due to the stratospheric ozone's ability to absorb it. The important substances such as chlorofluorocarbon, so called CFCs, widely used in refrigeration and other cooling system, aerosols, foams and solvents reach the stratosphere and causes ozone depletion. The ultraviolet rays hit the CFC molecules and free radical combines with O3 to form diatomic oxygen and chlorine oxide radical. A single of radical can break down nearly 1 lakh ozone molecules. This cycle continues and consequently the O3 concentration gets depleted. Now, let us see some basic fact about ozone depletion. First one, the Antarctic scientists experience the equivalent of standing under an ultraviolet lamp 24 hours a day. Exposed skin quickly burns and swells, and certain protective clothing deteriorate rapidly. Antarctic researchers have recorded steady losses in the ozone layer since 1970. Nothing, a huge temporary decrease every October. Each year, the ozone hole widens and deepens. In addition to ground-based measurement, NOAA satellites also record this alarming situation. At Earth's opposite pole, a similar ozone depletion over the Arctic exceeded 35% in 1989. Losses have increased in each subsequent year. Since 1922, the Canadian government regularly reports an ultraviolet index. In 1994, Environment Canada opened a new scientific observatory particularly to monitor the ozone losses over Canada. Overall losses in the mid latitude are continuing at 6 to 8% decade. Ozone levels in the atmosphere have decreased about 50% near the North Pole and the South Pole, about 4% over Australia and New Zealand, and about 3% over the subcontinent of India. The amount of depletion varies with the latitude because of variations in the intensity of sunlight. Even planktons in the uppermost 2 meters of ocean would be affected. Recent research indicates an alarming decrease in phytoplankton primary productivity between 6 and 12% in the coastal water around Antarctica. If the productions were completely halted tomorrow, chlorine levels in the stratosphere would continue to rise for another 20 to 30 years according to NASA source. Everyone must know the effects of ozone layer depletion on the earth. It is found that the increased ultraviolet B is a great threat to terrestrial vegetation. DNA absorbs ultraviolet B, results in mutated cells or the cells die, and the cells have developed the ability to repair DNA. It can affect both the timing of flowering as well as the number of flowers in certain species. There is a global decline seen in amphibians. It gives alarming that overexposure may increase risk of malignant melanoma, which causes skin diseases, severe sunburn, skin cancer, and suppresses immune system, causes an outbreak of rash in fair skinned people. Now, let us see the recent trend in ozone depletion. After that awareness of all those efforts taken by the Montreal report, in 2007 report says that slowly and gradually the hole was recovering, and it is the smallest in a decade. Because of the banning of CFC in industry, ozone depletion has mostly stopped with some sign that the levels are increasing. Steps to protect the ozone layer. After knowing all the consequences of ozone depletion, now it is a time for the developed and the developing countries to take precautionary steps to protect ozone layer. Minimize high altitude aircraft flights. Minimize rocket flight. Encourage growth of plants that produce oxygen and discourage deforestation. Decrease or control releases of high temperature steam or moisture to the atmosphere. Eliminate production and release of known ozone depleting chemicals such as chlorofluorocarbon where remotely possible. Subsidize production of safer alternatives wherever possible. Establish controls to assure that new compounds to be used in high volume are surveyed for effect on ozone. International response and the future. In 1994, the United Nations General Assembly voted to designate September 16th as World Ozone Day to commemorate the signing of the Montreal Protocol on that in 1987. So, September 16th is declared as International Ozone Awareness Day. The Montreal Protocol called for an accelerated complete ban of CFCs by the 1996. The hole in the polar ozone layer and the general depletion overall provide healthy problem. Hopefully, by taking action now, the hazards to life in the later half of the century will be reduced to some extent, and scientists believe that ozone will return to its pre-CFC level by about 2050. As individual can contribute to the same by following certain principles in his day-to-day life as follows. I can avoid or minimize the use of aerosols in my daily life. I can insist on a non-CFC refrigerator while buying. I can avoid the use of air conditioner wherever and whenever possible. To conclude, if we do not take the steps to reduce the depletion of ozone, it is sure that we will be in the red zone.